Okay, so this video is going to teach you how to use Google Colab to run regressions that is required in our assignments. So I'm going to do a run through of all the tasks that we are required to do. And along the way, I will introduce a lot of things about Python, about programming. So let's get started. First, you go to Google, search Google Colab, and you find this thing. Okay, so what you need to do first is you should open a new notebook. Google requires you to log in with your Gmail, which is pretty simple. So once you open this new notebook, you are onto this interface, okay? Think of it as your table where you write your paper. Or this is your calculator, your playground, okay? All right, so I have given a lot of instructions about how we should proceed, but we'll do that step by step. First of all, you need to upload the data to the Colab folder on the left because the computer doesn't know what kind of data set that you want to work on. So go to the left-hand side, click on this files. After 1 or 2 seconds, you can see here, there is an upload. The first task we were gonna do is on this growth data set. So upload it. It says that reminder uploaded file will get deleted when the runtime is recycled, which means that you probably don't want to open this and go away, and then it would logged out on its own. Okay, so you want to do it all together. All right, so first we have the data set. Now we want to do that step by step. First, load your libraries. Okay, so in Python, everything is an object. A data set is an object. A number is an object. A function is an object, and libraries that contains a lot of functions is an object. And so you can think of, we need libraries that there are functions that are written by people that we can use to run regressions so that we don't need to write a regression function on our own. Okay, so what you're going to do is copy this code, paste into your first code block. Okay, so these 3 lines of codes will first install an updated version of a library called XLRD. Second, it's gonna import 2 libraries and rename them. So pandas is a library that contains a lot of functions, including how to open a data file, how to look at a data file, and how to do some simple manipulation over a data file. So pandas is a library. This library has a lot of books. You can think of each book is a function. And as I said, every function, every library is an object. The second library is called stats models. Stats model, you can think of it as a large library that has a lot of different models in statistics. And API is, think of it as a sub-library or a sub-room in this library. Okay, so statsmodels.api also have a lot of functions. API is an object that belongs to stats model. So that's how this dot means. If you're interested in more more about programming, you can read about Python and what this dot actually means. So we want to use functions in statsmodels.api, but when we want to use it, we don't want to say, oh, can you give me a function from statsmodels.api? This is a very long name, so I want to give it a new name called SM. Okay, so then from now on, if I said to the computer, give me a function from PD, then it means give me a function from the pandas library. If I said, give me a function from SM, it means give me a function from the statsmodel.api. Okay, so on a Mac system, you can click, or you can push Shift plus return. On a Windows system, you can push Shift and Enter. You can also use your mouse, which is clicking this Run Cell button on top of this, on the left-hand side of this cell block. You click Run, it's running, and it shows that it's run. And once you see this green little check mark on the left-hand side, it means this close block is, this calculations are done. Okay. So next, we're going to repeat what we did, which is adding an extra block of code. Come back to the codes I provide you, copy, paste, and run. Okay, so the next block is I'm gonna give my name to this data set called data frame 1 or DF1. DF1 is a data from Growth.xls Excel file. PD is, as I said, the library that contains a lot of functions that can load data sets. So PD give me a function called read Excel from the pandas library that read into this data set. And then within this data set, I'm gonna use a function called head, which is a part of the function that DF1 has, which is show me the first 5 lines or 5 rows of this data set. Okay, so now we can see the first 5 rows. There are many rows of this data set, but we're only seeing the first 5, which is India, Argentina, Japan, Brazil, and United States. So these are a bunch of countries. The first column is country name. The second column is the GDP growth. The third column is whether they have oil, and many other X variables. Okay. Okay, so let's repeat what we did. Add a code block, copy, paste, and run. Okay, so the next part is finding summary statistics. So describe is a function. We're gonna use describe function to operate on DF1, which is an object, which is a data frame. So now we can see that, oh, there are 65 data points for each variables, which means we have 65 countries. We have mean for all the variables from growth to assassination. We have standard error, we have minimum and maximum, and also for 3 quartiles. Okay, so this will answer part of the questions on the homework. So let's keep going. So now we want to run regressions, but before we run regressions, we have to create a variable that represents the beta 0. So beta 0, you can think of beta 0 is beta 0 times x0, except that x0 equals to 1 for all the countries, so all the observations. So I want to create a column that is an x0 or constant, and this constant equals to 1. Okay, once you run this, you can see that the DF1 head now looks like this. So everything is still the same from India to United States, from country name to assassination, but we have an extra column called constant or const, and it equals to 1 for every single object. Okay, so now we can run this regression. We add a block, copy, paste, and run. If I forgot to tell you, then this green lines that started with a hash, it means that it's comment. So these are comments that I put into here. And when the computer sees it, they will realize that those are sentences. Those are not computer codes. Okay, so let's see what this is about. So the first line, regression 1, as I said, everything in Python is an object. A regression is an object. And this regression one is using the OLS function from SM. Remember, SM is a sublibrary of stats models. We're calling this function, and we have several inputs that we put into this function. The first input is an endogenous variable. An endogenous variable means that it's our Y variable or our dependent variable. So our dependent variable comes from data frame one's growth. Okay, growth from data set one is our dependent variable or our Y. The second input is all the X variables. Okay, so it's called exogenous variables. So exogenous variable equals to df1. And it contains first an X variable that is trait share. And secondly, we need beta 0. So here it's X0 in the name of constant, but basically it is a variable that equals to 1 for every parameter. Okay, so when we write regressions or in our textbooks, we usually don't use this. But for some reason, because stats model wants to consider situations when there is no beta 0. So we have to put this beta 0 here. Just not to feel confused about this. This will not cause multicollinearity because this is modeling beta 0. Okay. All right, and the second part is results. As I said, result is an object. And this object is using the fit function to fit this regression. Okay, some people might think fit is a hard to understand concept in Python, but basically at the beginning, you might find it a little bit uncomfortable that didn't I already ran the regression? The fact is that you have specified the input, but you haven't run this regression yet. So reg1.fit is going to use a function called fit to fit this regression one. And the result is what you get after the fitting. Okay, so next, result.summary. You can think of it as summary is a function that summarizes everything so that it's presentable, and then you print it out. So results is an object, summary is a function. It's also an object that summarizes the results so that you can print it out. And here is what you see from here. If you don't print it out, then all of this information will be hidden in results. So because we want to see it, we want to answer the questions in our homework, we have to print it out. All right. So here's the results. This is beta 0. It is 0.64. This is beta 1. So when trait share increased by 1 unit, Y increased by 2.3064 unit. This is standard error. This is the standard error for beta 1. This is standard error for beta 0. You don't need to calculate T statistic. It's calculated for you. T statistic for beta 1 is 2.9. P-value for a two-sided test for beta 1 is 0.004. This is a very small p-value, so we can reject at, let's say, 1% significance level. Okay. All right, so this is the first regression we run. It is a regression that has beta 0 plus beta 1 times x1. It only has one x variables, except that in Python, in stats model, you have to put constant term into it. So it looks like you have two x variables, but one of them is beta 0 times 1. Okay. All right, so keep going. The next question asks you if there's omitted variables, so you have to control all the other things. So you define a regression number 2, everything else is the same, except that in exogenous part, you have all the other x variables and constant. Okay. You fit regression 2. into results, I would say a better practice here is name this result as result number 2, because you don't want 2 results to have the same name. Otherwise, it will overwrite the previous one. Okay, so think of it as result 2, and it will print the summary of result number 2, which is result number 2 is actually a fitting of regression 2. Okay. All right, so now we have regression 2. You can see that we have more rows here, right? So this is beta 0, this is beta 1 all the way to beta 5. And on the same row, you have standard error, t-statistics, p-value for two-sided test, and 95% confidence interval. So this is 95% confidence interval because it comes from 2.5% to 97.5%, which means in the middle, there's 95%. Okay, so this will be information that you need to do your homework. The next question asks you to drop Martar because Martar has a lot of trade. Okay, so now I'm going to define a data frame called data df2. df2 equals to df1. So here I'm copying df1. Okay, and the second step is I want to drop the last country, which is in index 64. Okay, so remember Martar is at the bottom, which should be the 95th country, right? So why do you drop index equals to 64? The answer is that Python index from 0. So you have 0, 1, 2 instead of 1, 2. Okay. If you come back here, you see that the first country did not start from index 1. The first country start from index 0. And this is just basically a way that Python's general rule that everything starts from 0. So the 65th country is at index 64. Okay, so once you do that, and you run and you show yourself the head of, which is the first 5 line of df2, you will see that it's still the same because you drop the first, you drop the last country. So the first 5 countries should be the same. But if you look at df2 on its own, then it has 64 rows, which means that now we have 1 less country. And this country is number 64, which is Martar. And we don't see it anymore because it was dropped. Okay. Same thing, we run a regression using df2, which is without Martar. So we define the regression 3, we fit this regression 3 and print the results of regression 3. A better practice is to use results. Okay, result 3. Okay, so here is what you get. You will see that the regression here is a little bit different from this coefficient, which means that taking out an outlier value can significantly change your regression results. Okay, and it becomes a little bit insignificant as well. Next, back to df1, we want to add the variable oil. Okay, so this is results 4. So oil hasn't shown up in this regression. Okay, it means that stats model on its own dropped oil as an X variable. It just simply thinks that oil shouldn't belong here. And you might ask why. So the reason is that if you come back here to the summary statistics, So oil has 65 observations. Its mean is 0. Its standard deviation is also 0. Its minimum is 0. Its maximum is also 0. So it simply says that oil is a variable that has no information, that it has no information on the variation. Okay. So why do we say that? Because when we talk about R squared, we always say that how much variation of Y is explained. So if you want to explain variation, you yourself has to have variation, right? Otherwise, you cannot explain anything. And in this case, these 65 countries, none of them have oil. And so if you run a regression of GDP on oil, and none of them have oil, then you have no idea what's going to happen to a country's GDP if they have oil, because all the data that you have no oil. So basically, if an X variable has no variation, it doesn't belong. But you might ask, how about constant then? The fact that we model constant is that in stats model, it needs a requirement, or it needs a variable that can model beta 0. So constant can have no variation, but all the other X variables that you put in has to have variation. Otherwise, the Python would just get rid of this thing and say, we cannot calculate anything. Okay, we'll just calculate the rest of the X variables that you provided us along with this beta 0. Okay. All right, so this is about growth. And I'll put this code on a website that's linked, and I'll put it in the description side so that you can access these codes.